So let's sketch the region of integration R and evaluate the integral over R using polar coordinates. So first thing, let's figure out what we're talking about here in terms of this region. X squared plus y squared is less than or equal to R. That means I have a circle with radius 3. But y is positive, so I only want the half circle above the x-axis. So that region is going to look like this. So I want to integrate over R 2xy dA, but I want it in reference to polar coordinates. So dr d theta, but this is funky because the x and y. And that's like x and y is just not just simply r. I need to work with that a little bit. If you remember, the conversion back and forth from Cartesian to polar coordinates consists of x equals r cosine theta and y equals r sine theta. So that's exactly what I'm going to do. I'm going to take x and y and substitute it for r cosine and r sine theta. And of course, there's going to be an extra r here that I didn't put in when I convert to polar coordinates. So I'm going to end up with this double integral. R is going to go from 0 to 3. And if y is positive, that means I'm going to go from 0 to pi in terms of theta. And I'm going to pull this constant 2 out here. And I'm going to have r cubed cosine theta sine theta d theta. Now, there's a couple things I can do with this. I can go ahead and do a u substitution. Whoops, I'd have d theta here. I forgot my dr d theta. I can go ahead and rewrite this when I do theta, do u substitution and so forth. Or I can recognize the fact that 2 sine theta cosine theta is the same as sine of 2 theta. Now, actually, let me actually make this a little bit easier to integrate. So I think I'm going to do that right now. I'm just going to rewrite this. See, 0 to pi, 0 to 3. I'm going to have r cubed times sine of 2 theta d theta. I'm sorry, I keep writing d theta. I keep skipping my dr. So dr d theta. Now I'm going to go ahead and do this integral with respect to r first. So I'm going to end up with r to the 4th over 4 evaluated from 0 to 3. So this is 3 to the 4th, which is 81 over 4 minus 0. So now I'm going to take 81 over 4 times the integral from 0 to pi of sine of 2 theta d theta, which is going to be negative 81 over 4 cosine of 2 theta over 2 evaluated from 0 to pi. So obviously I can make that an 8. And matter of fact, I will. Negative 81 over 8 times cosine of 2 theta evaluated from 0 to pi. So that's negative 81 over 8 times cosine of 2 pi is going to be 1. And then at 0, I'm going to have cosine of 0, which is 1. So 1 minus 1 is 0. So the whole thing is just 0.